Okay, so I've started recording, and perhaps you saw it on Moodle that I made a link to the YouTube that has Mondays. Probably most of you won't listen to that one because hopefully it was basic enough. It's about 18 past 9. One of the ways that you can use this is, now that I've told you the time, is if you're confused about anything and maybe I'm not answering the right questions or maybe I've just blown over something, just write down the time. Then when you go back to the recording, you don't have to listen to the whole thing. All you have to do is zip ahead and look at that one particular slide for that minute. So it'll be a little bit more efficient way to look at things. Okay, so we back up to where we're starting, operations with real numbers. When we have like signs, we just add the numbers, apply the negative sign. When we have unlike signs, what we do is subtraction. We take the larger one, subtract the smaller one from it, and then apply the sign of the greater one. So if we have 5 minus 6, that's 6 minus 5 is 1. Since the sign of the 6 is negative, we apply that to the 1. Same thing with the negative 11 plus 5. You take the difference between the two of them, that's 6. Since the 11 has the negative sign, you apply that to the negative 6, and you're set. So addition and subtraction in this sense are equivalent. And so we can write things like 5 plus negative 6 is the same thing as 5 minus 6, and negative 4 minus negative 3 is the same thing as, in parentheses, negative 4 plus negative 3. Now, one of the reasons why I write it like this, and I think it's useful, is that when you'll see later when we're trying to evaluate expressions, that using parentheses to keep your signs straight is a really, really important way to avoid mistakes. And so certainly would like you to write as much as you can when you're showing your work. Put things in parentheses. It'll really help you keep these signs straight. And so going from let's say that negative 4 minus negative 3, the right-hand side of that, the negative 4 plus negative 3, that may be what you're putting in an equation. Then you use the next line to simplify that into the operation on the left side. Okay, so when we have fractions, what we want to do is, when we have the same denominator, we just add the numerators. So if we have 3 sevenths plus 2 sevenths, you get 5 sevenths. If you have unlike denominators, you have to make a common denominator. And with the common denominator, what you want to do is find the least common multiple. And so the way you do this is you factor the denominators. And in this case, 12 is 2 times 2 times 3, and 20 is 2 times 2 times 5. Factor it out to the prime factors. And then your least common multiple, what you do is you decide, okay, there's a pair of 2's in each of those factors, and so we're only going to use them once. And then put in the unique factors after that, which are 3 and 5, and when we multiply all that out, that is that's 60. Now, I know a lot of you, when you're adding something like 3 twelfths and 5 twentieths, would want to take the product of the two for the common denominator. 12 times 20 is 240. You could use that as the denominator, the common denominator, but you're just going to be doing a lot more work in terms of simplifying your ratios at the end. Plus, when we get into adding ratios of algebraic expressions, if you do it that method where you just take the product of the two denominators, you're going to cause yourself a lot more work than if you learn or you practice at using the common denominator as the least common multiple. So then, to work this one out, to get from 12 to 60, we have to multiply that by 5. So we multiply that fraction by 5 over 5. And then to get from 20 to 60, we multiply by 3. So we multiply the numerator and the denominator by 3 over 3. And coincidentally, we get 15 plus 15 over 60, which then, of course, simplifies into 60 thirds or 1/2. I can't emphasize enough, for you to practice this now, that you're able to factor denominators and come up with a least common multiple to add your fractions this way. It may seem like it's a little bit more work at first, but like I said, with the algebraic expressions that we're going to use, it's going to be really the only efficient way to do that. Okay, operations with real numbers. Multiplication is next. And so multiplication, if they have like signs, you always get a positive. So 3 times 5 is 15. Negative 3 times negative 5 is, ooh, look at that. It should be positive 15. Let me correct that. How's that? Does that look like a positive? Not really. There. Okay. So now when you have opposite signs, the product is negative. So we have 3 times negative 5 is negative 15. Negative 3 times 5 is negative 15. Fractions, unlike adding fractions where you just work on the numerator, once you have a common denominator, you don't need a common denominator, but you multiply both the numerator and the denominator. So 3/5 times 2/7 is 6/35. Now there is something with factoring that I think would be helpful if you get used to. Rather than multiplying this 12/35 by 14/21, rather than multiplying out 12 times 14 and 35 times 21 and then seeing if you can reduce it, if you fully factor the numerator and the denominator, what you can do is you can cancel out the factors that you already have, like there's a common 3 and a common 7 between the numerator and the denominator. And then what you have left over is 2 times 2 times 2, which is easy to do. It's much easier than 12 times 14. In the denominator, you have 5 times 7, which is a lot easier to do than 35 times 21. And so you get 8/35 as your answer. The nice feature about using this method is that you're guaranteed to have a reduced fraction when you've finished this. Now, if you're going to reduce the fraction after you do the multiplication, you're going to factor it anyway. And so since you're starting with lower numbers, factoring smaller numbers is easier than factoring larger numbers. So really think in terms of multiplying to take out, to factor it and then cancel your factors. This is one of the reasons why we don't let you use calculators in this class, is because there's a lot of very precise math that you can do and get to nice integer ratios without introducing rounding errors, and you get a little bit better of a number sense. Certainly you can do 12/35 times 14/21 in a calculator, but it really doesn't, you'll get that number that really doesn't tell you as much as 8/35. And 8/35 is exact, it's never rounded. Okay, so next we have division. A divided by B is the same thing as A times 1 over B, or A divided by B. Now here's the terminology. The first number, that A, is the dividend, B is the divisor, and we've already used the terms numerator and denominator for that, that ratio. That's the answer. The result is the quotient. Now you won't hear the word dividend and divisor used very much, at least in this class. That's those are precise words that you can use to describe things, but certainly the quotient is something that is a word that you should be very familiar with. That's the result of a division. Okay. And so A divided by 0 is undefined. Don't let anybody ever tell you it's infinity or anything like that. It's just simply you can't do it. You don't get a number. Now we have exponential expressions, a to the n. Just like multiplication in a sense is a repetition of addition, like if we do 4 times 3, that's the same thing as saying 3 plus 3 plus 3 plus 3. Exponentiation is like a repetition of multiplication. A to the n is taking a times a times a, doing that over n times. So if we have 3 squared, that's just 3 times 3. 2 to the 5th is 2 times 2 times 2 times 2. And then fractions work the same way, where you're multiplying it by each other 3 times. And so 1/2 cubed is 1/2 times 1/2 times 1/2. Now I use that word cubed. We use, when we have an exponent of 2, we call that squared. When we have an exponent of 3, we can call that cubed. And that's because it's often used in terms of shapes. Like if you take a square that has 3 on the side, then 3 squared is going to be 9, which is the area of that square. Same reasoning with the cube, that we get volumes that way. So we call the exponent, and we call that a, we call that the base. And so probably most people are familiar with addressing that n as the exponent. What is less common is knowing that you refer to the a as the base. And so we have a nice precise word to describe that. So we can say 3 to the 5th power is spoken like that. You could say 3 to the 5th, raise 3 to the 5th power, any combination of that, to be able to read that out loud. And then we have some zero rules. 3 to the 0, in fact, anything to the 0 power is 1. 0 to any power is 0, right? 0 cubed is 0 times 0 times 0, which is 0. But 0 to the 0 power is undefined. That's just the same as division by 0. You just don't get a number. There's no number that's equivalent to. So you have 3 different cases with zeros. If it's in the exponent, you get a 1. If it's in the base, you get a 0. If it's in both the exponent and the base, you don't get a number. Now, signs carry on through. And so if you have -3 squared, that makes 9. -3 cubed is -27. Now, we have to think about order of operations here, and we'll get into order of operations. But notice I put parentheses around the -3. That's different than saying -3 squared. -3 squared would be squaring the 3 first and then applying the negative. If I put -3 in parentheses and then square it, that means I'm squaring the whole number, including the negative sign. So that's the first rule of order of operations, that parentheses overrides everything. And parentheses, I want to encourage you to use parentheses very liberally. It's one of the best things you can do to guarantee or to ensure that you're going to make accurate calculations. Now, after parentheses comes exponents. After exponents comes multiplication and division, and it goes left to right. Multiplication and division have exactly the same priority. So when we have 4 divided by 2 times 3, that's going to be 2 times 3. So you do the 4 divided by 2 first, and then you multiply by 3. You don't do it like this. You don't say, well, the 2 times 3 first, and then you do 4 divided by 2 times 3. You don't want to do that. And then the lowest priority is addition and subtraction, left to right again. And you'll find that this one doesn't really matter. We're going to get into a property called the associative property, so order doesn't really matter too much. I would say virtually every high school math class teaches PEMDAS. And you got to be careful with PEMDAS because multiplication and division have the same priority, and so does addition and subtraction. PEMDAS would imply that multiplication has a higher priority. You do those first before division. That's not true. You do multiplication and division left to right. Okay, so those are your basic operations. That's section 1.2.